Hey guys, and welcome to the Radix Sort sorting algorithm tutorial video. In this video, we'll discuss the Radix Sort algorithm and how it actually works. So, the Radix Sort is actually a pretty interesting and unique algorithm because it does not make comparisons between the values in the list. So, how is that actually possible? How can we sort a list of numbers without actually comparing them to see if one is greater than the other? Well, we're going to see that and a lot more in today's video. So let's proceed. Alright, so here is the list of numbers to be sorted. Now, basically this video is going to be divided into three sections, alright? In the first section, which is the one we're on right now, I'm going to show you a worked example of how Radix Sort actually sorts an array, alright? In the next part, we'll actually take a look at the code for the Radix Sort algorithm. In the third part, we'll take a look at how Radix Sort compares to other algorithms, and then we'll just generally talk a bit about Radix Sort and where it's used. Alright? So if you don't understand something in this part, alright, then wait for the coding part, alright? Because some of the more technical details on how some things are being done is something we'll discuss in the coding part, alright? For now, just focus on how Radix Sort actually works, alright? And its general concept. Okay, so notice over here is that we have a wide range of numbers, alright? We have single digit numbers, we have double digit, and we have 3-digit numbers as well. Okay, so Radix Sort's basic concept is of using buckets and passes. Now, what is a bucket? Well, imagine a literal bucket, alright? Imagine a literal bucket as a slot. What we're going to do is create 10 buckets. Now, why 10 buckets in particular? Well, that's because there are 10 numbers from 0 to 9. So we're going to create one bucket for each number. And then we're going to put these numbers into these buckets, alright? After checking for a certain condition. More on that later. So Radix Sort can actually also be used for strings. So in that case, you would make 26 buckets, alright? Because it's from A to Z, there are 26 characters, so you would make 26 buckets, alright? So yeah, but right now we're doing numbers, so it's 10 buckets. Another thing that you should know is that Radix Sort makes passes. It makes passes based on the number of digits of the highest number. Now, what is the largest number here? Now, 20, no. 384, no. 21, 273, no. 8, no. 922. 922 is the largest number. So that's the first thing we do in the Radix Sort algorithm. We locate the maximum value. And then we check to see how many digits does it have. Well, 922 has 3 digits, 9, 2, and 2. Alright, so it has 3 digits. So we're going to make 3 passes. Now, what are we going to do in these passes? Don't worry, I'll explain that. Now, let's actually move ahead to the next section. The next slide. Alright, so here's our pass table, alright? Now, this may seem like a whole lot to take in at once, so just calm down and slowly take a look at it and let me explain things pass by pass, bucket by bucket, alright? We're going to be on this slide for the next 5 minutes, alright? So, stay calm. So, pass 1. What we're going to do in pass 1 is sort, well, not sort, alright? I don't want to use the word sort here because we're not comparing and sorting. What we're going to do is place the values into the bucket based on the first digit, alright? And the first digit I'm talking about from the right, okay? So the the unit 10 and 100 digits, that system we used to learn. So think of it that way. So we're going to be looking at the unit digit right now. Okay. So we're going to be putting them into the buckets from 0 to 9. All right. Based on this this digit, the unit digit. All right. So let's actually begin sorting these values and putting them into the correct buckets and doing all 3 passes. Let's come back to this slide, all right, which shows the original list of numbers. Okay, so number 20. That's the first number that we're going to be dealing with. Now, what we're going to do is locate the correct bucket to put this into. Now, we do this, again, as I mentioned earlier, we do this based on the unit digit, all right? And in this case, the unit digit is 0, which means that we're going to put this number into bucket 0, right? Now, we'll cover this mostly in the code section, but I'll just briefly describe here how to actually, locate this unit digit, all right? How to find 0, all right? These aren't strings, so you can't use string indexing here or anything, all right? But a very easy way of doing this is using the mod and floor division, all right? So in this case, all you have to do is mod 20 by 10, okay? So if you don't know what modulus is, modulus returns the remainder. If you divide 3 by 2, okay, the modulus will return 1, because that's what gets left over, right, when you divide 3 by 2, okay? So in this case, 20 mod 10 gives 0, all right? It's a clean division, all right? 20 divided by 10 gives 2, all right? There's no fraction involved, all right? So in this case, 20 mod 10 gives 0. So we'll use this return value 0 to put it into the correct bucket 0. So our code looks something like index, where index is a variable. Index is equal to 20 mod 10. It's a bit more complicated than that, but we'll get more into that later, okay? So yeah, now you can see clearly in this pass table that 20, the value 20 over here, okay, at the very top, is in bucket 0. Okay, so next is 384. Now let's mod this by 10. What do we get? We get 4, all right, because of this value. And let's put that into bucket 4. Okay, we can see that over here, it's in bucket 4. Next is 3. This is, again, very simple. It'll go into bucket 3. Okay, you can see that over there. The value 89, it goes into the 9th bucket. Okay, then the value 53, it goes into the 3rd bucket again. Okay, and remember, each bucket is its own list. It's a separate list. So we're just appending onto that list. So basically, we have a 2D list here. Okay, it's a 2D list that has 10 lists within it. And of course, each list is the bucket. Okay. All right. So 21 goes into the first bucket. 73 goes into the third bucket again, and 8 goes into bucket 8. And over here, this value 922 goes into the 2nd bucket. So that's the first pass complete. Now I want you to notice something rather interesting. If you just look at the first digits, the unit digits of each number, you'll notice that we have a perfectly sorted array. Watch. Over here you can see 0, 1, 2, 3, 4, and there's nothing over here, of course. So 5, 6, 7, 8, and 9. Now just keep that in mind. This will make more sense in the next pass. Okay, so we're on pass 2 now. All right. Now here's a slight change. Well, the change is mostly in the code, so you won't notice that here. But basically, we now need to look at that digit 10, the digit at the 10th place. So basically, 20 over here, all right, we look at 2, okay? We get the value 2, and then we put it into bucket 2. Now, again, I'll give you a brief intro on how we're actually going to do this in the code. So what we do is floor division, all right? Basically, we divide 20 by 10, okay? 10 is actually to the power digit, okay, where the digits actually start from 0. So again, if you don't understand this right now, that's fine, all right? I'll explain this again in the code section. So we do 10 to the power digit, okay, where digit starts from 0. So in this case, we have 3 digits in total, right? 3 max digits. So we do 0, 1, and 2. Now, in the first pass, 10 to the power 0 is 1. So that's why the division didn't show, okay? So we just cleanly modded 20 by 10, all right? So the code was actually index is equal to 20 divided by 10 to the power digit modded by 10. Okay, now again I told you, because the digit was to the power 0, okay, we didn't notice it in the first pass, but now we're basically in the second and third pass, this actually makes a difference. So what we're going to do is first divide 20 by 10, which gives us 2, and then we'll mod this by 10, which gives us 2 again, which makes it go into the second bucket. And there you go, 20 is over there. Okay, now let's take a look at this one, 384. Now I mentioned the term floor division once or twice. So what floor division basically is that if you divide a number like 384, okay, if you divide this by 10, we'll get 38.4, right? What floor division does basically is it removes the fractional part. So instead of giving us 38.4, it gives us 38, all right? Then we'll mod 38 by 10, and then we'll get 8, all right? Pretty simple and straightforward. This goes into the 8th bucket, all right here. And here's 3 now. Again, there's no need to complicate this. One useful trick that you can use when you're dealing with second and third passes on small numbers like 3 over here, it's a single digit. So you might think of it, and how are we going to divide this by 10 and stuff. You don't need to actually think that hard on it. Imagine that there's zeros, right? Imagine that there's some extra zeros over there. Imagine that instead of 3, it's actually 0, 0, 3. Okay? You can sort of imagine all of these as the 3-digit numbers. But there's a 0 over there, like 0, 2, 0. It doesn't make an effect on the actual number. It's just there to sort of help with your concept if you find that it makes it easy to understand. So yeah, 3 divided by 10 is equal to 0.3, but since we're doing floor division, it's is equal to 0, and then 0 mod 10 is equal to 0. So we put that in bucket 0. And then there's 89 over here. It's the same thing. We divided by 10, we get 8, modded by 10, and we get 8. So we put it into bucket 8. So you can see it in bucket 8 over here, 89. Okay, and 384 was already there, all right? So that's why 89 gets appended after it, okay? And you can look at bucket 0 over here. There's 3 over there. It's not actually 0, 3, it's just 3. I just put the 0 over there just so that you could sort of visualize it, all right? Okay, so back here. Now 53, 21, 73, 8, they're all done in the same manner, all right? There's no need to repeat that. Let's take a look at 922. So we'll divide that by 10. We'll get 92.2 rounded off. I'm sorry, floor division. So we get 92. Modded by 10, we get 2. Okay? And then we put that here in bucket 2. Okay, so now let's take a look at something a little further ahead. Okay, so this is what the array looks like at pass number 2. Okay, if you were to sort of take all the buckets in pass 2 and append them together, okay, you would basically get this. I want you to notice something now. If you were to remove the 2 3-digit numbers, we have a perfectly sorted array. You see that? So basically what's really happening is that the first pass sorts all of the numbers based on the first digit. So basically every single digit number in the first pass will become sorted, all right? It'll be in its correct position relative to each other. In the second pass, all the two-digit numbers and the first digit numbers will become sorted. And in the third pass, we'll sort all numbers, the single-digit ones, the double-digit ones, and the three-digit ones. So in the third pass, these 922 over here and the 384 over there will become properly sorted, all right? So yeah, let's get back into the pass table. Okay, so let's move on to the third pass now. So 20 over here, basically now we're going to increase the division, the division operator. Previously we were dividing by 10 to the power 1. Now we'll divide by 10 to the power 2. Okay, so it's 20 divided by 100, which gives us 0, and of course modded by 10, that gives us 0. Okay, and this is going to be the case for anything that's not a 3-digit number. 20, 3, 89, 53, 21, 73, 8, they're all going to go into the bucket 0, because you divide them by 100, they all give 0, right? Floor division. So let's take a look at 384 and 922. So 384, divide that by 100 and you get 3.84 floor division, so you get 3, modded by 10, you get 3, it goes into bucket 3. 922, divide that by 100, you get 9.22, floor division, you get 9, modded by 10, you get 9, which makes it go into bucket 9. Okay, so now let's properly take a look over here. This is what it looks like in the first pass. Okay, again, there's not much to look at over here. This is what it looks like in the second pass, and this is what it looks like in the third pass. Okay, so now we're done here basically. Now let's just go back here, and I want to show you over here basically that we're basically going to add together these 3 lists. Okay, we're going to add bucket 0, add bucket 3, add bucket 9. Well, we're actually going to be adding all of them, alright? But since there's nothing in bucket 1, bucket 2, bucket 4, bucket 5, bucket 6, bucket 7, bucket 8, it won't make a difference. Okay, so now we're done with the visual representation part. Okay, so let's actually get to the code part. Okay, because there's still one step that I can't actually explain over here, and the step has something to do with flattening the 2D list into a 1D list, because this is still a 2D list. All right, these are 3 separate lists. This is not one list. Okay, the stuff I'll show you over here, this is just for visualization purposes. Okay, so that's the one step left that I'll take a look at in the coding section. All right, so let's move on to that. All right, so here we have 3 functions. The main logic for radix sort is in here, but the other 2 are utility functions that help us during the process. So this one is pretty simple, and there's no need to explain it too much. But basically what it does is that it finds the maximum digit, all right, and then it stores it in max digit, and then we convert it to a string, and then we find out the length. So what this basically does is returns the number of digits in the greatest number. Okay, and we did this using the max function. Right, it's an inbuilt function in Python. All right, finds the maximum value. Okay, so here's the list flattening. More on this later, but it's used to actually combine the lists. All right, from 2D into 1D. What it basically does is combines all those 1D lists in the 2D list into one. All right, that's what it does. So that's what the plus here is actually about. Okay, it's just it's an inbuilt function. It's part of the func_tools library. You just need to use it. All right, like this. I'll also make a video on flattening 2D lists into 1D lists, because there are actually like 4 or 5 ways. You can even make your own. You can use list comprehension. You can use reduce. You can use sum as well. So let's just move on to the radix function now. All right, this is the main part. So over here we call num digits, okay, and then we store the digits in digits, and then we set up this for loop. This is the for loop responsible for the passes. Okay, so the largest digit here is 922, and it has 3 digits. So we run the for loop from 0 to 2. And that's what I meant earlier when I was talking about like 10 to the power 0, 10 to the power 1, 10 to the power 2. This is what I meant. Okay, so this is where we create the buckets. Okay, you can just call this buckets if you wanted to. I just call it temp because it's just a temporary array that you'll recreate each time, in each pass. Okay, and over here we iterate over the array now. Okay, and what we do is num. This is basically the index. You can also think of this as index. Okay, so we do index is equal to item, which is the value, like for example 20. Okay, so we floor divide this. This is the symbol for floor division. This is division, this is floor division. All right, that's it. So here we divided by 10. Since this is 20 we're talking about, and in the first pass, so it'll be 0. Okay, digit will be 0 because of this over here. It starts from 0. Mod 10. So 20 divided by 10, which is 2, mod 10, which is okay, hold on, sorry. This is the first pass, right? So digit will be 0, which means 20 divided by 1. All right, 10 to the power 0 is 1. So 20 mod 10 is 2. And then temp 2. So basically, it's like this. Temp 2, index number 2 of the 2D list temp, and which means bucket 2. You can also think of it as bucket 3 because we start from 0, right? Bucket 0, bucket 1, bucket 2. So don't get confused. I've actually maintained the notation from 0 from the start, so I'll just use that. When I say bucket 2, it's bucket index 2. Okay, it's not bucket number 3 literally. Okay, so yeah. And of course, we just append this to that index, all right, or to that bucket. We append that value, all right. So we do this for all the values in the array, and then we flatten it. We call the flatten function. So basically, what this does is that all the different lists, okay, that were created in the temporary array, it flattens all of them into a 1D list and puts it into array as the new array. Okay, so then this repeats again in the second pass. We come over here, recreate the buckets, iterate over each value again, but this time with digit is equal to 1. So, and I explained all this earlier. So we do this 3 times, and by the end of it, we have a fully formed array. Okay, so let's just run this once. Okay, there you go. You can see that right there. And if possible, there's something I want to show you. I want to show you what it looks like. I want to show you what temp looks like. Okay, there you go. This is pretty handy, I think. This will probably help improve your concepts. You can also cross-reference this against the pass table I showed you earlier. So you can see over here that this is the bucket 0, this is bucket 1, this is bucket 2, bucket 3, bucket 4, bucket 5, bucket 6, bucket 7, bucket 8, bucket 9. All right, you can see they're all sorted accordingly. And remember the third pass, where all of them were stored in the first bucket, because the 100th digit on each one of these is 0. And then this is stored in the third bucket because it's 3 over there, that's 9, so it's stored in the last bucket, bucket 10, or bucket 9, depending on which way you want to see it. So yeah, that's about it for the code. I mean, I don't think there's anything left to explain. So let's just briefly discuss radix sort now, as a sorting algorithm, and compare it to the others. Alright, so one thing about radix sort is that it is really, really fast for numbers. Alright, and if you're trying to sort a very large list of numbers, radix sort is a great choice. I believe there have been comparisons where radix sort is like 3 or 4 times faster than other sorting algorithms like quicksort. So yeah, that's really something. Especially for small numbers. Like by small numbers, I mean digits, like single or double digits, for instance, or even triple digits. So that also helps, because the smaller the number is, the less number of passes you'll actually require. Okay. So yeah. Okay, so this has gone on long enough. There's some extra information on radix sort available in the actual website, because I'm actually adapting this from my actual website. All right, this is a video version of the tutorial over there. So there's some extra information available there, like best case scenarios, the big O notation, time complexity, and a few other things. I'll leave a link in the description below, so you can go check that out. All right, I really advise you do. All right, so I think that's about it. Of course, we'll be making more videos like this in the future. We'll be covering other sorting algorithms, and you'll get to learn about a whole different bunch of techniques and stuff. So be sure to subscribe, and I'll see you in a later video.